There has been many changes in digital color devices. The most notable is changes from CRT to LCD LED, high-quality image. The unchanged technological element is how to represent colors on the digital media. The unchanged element of digital color processing technologies, for example, RGB and its mechanism. The color itself is subject of an art, however, display technologies or computer graphics technologies are engineering technologies which require some expertise on conventional knowledges. It also feedback to digital art too, not only applied scientific perspectives. The author of this book Toming Sop is digital color processing technician, worked at KIST and ETRI for more than 30 years, veteran technician. He explains complex chain of principles about digital color processing with ease of understanding. The book Digital Color의 기본 원리 is the most highlighted one, amazed edition of rarity in Korean publication industry, scarcity of its availability and clear and precise explanation about digital colors. Many Korean scientists often start their books with the call to accurate use of words in scientific purpose. The author does it in this book too. It is very successful beginning, very helpful for grasping conceptions more clearer, which is very basic but sometimes we ignored it. The completeness of the quality in this book of this feature is just beginning. The quality of authorship in this way continues to the whole book. The explanation is very useful to delineate basic concepts about digital color processing. The famous conceptions of the definition of digital colors, device representation of these colors, and methods such as additive mixture of colors, we can draw more attention on why CSS color scheme is representative to the form sharp FF00FF, although this is trivial but deep dive into it, very important feature of this book. The modern digital devices use RGB and they're each channel, 8 bits per channel, representing it into digital format. R is red, G is green, B is blue. R, G, B are respectively 8 bits. The binary representation is from 00000000 to 11111110. Decimal form is from 0 to 255, hexadecimal is from 0x00 to 0xFF. So, each channel can express 256 tint of colors, total 16,777,216 variations, and whole color is represented intensity of each channel, blended as an additive mixture of colors, sharp FF0000 as pure red, sharp 00FF00 as pure green, sharp 0000FF as pure blue, and more mixtures such as sharp EF003A or sharp DDD are available. This notation is defined with hexadecimal form. In this background, digital circuit represents colors with intensity of voltages, which is understood as most fundamental fact on digital color representation. There is device color characterization, to calibrate colors dependent on devices. The device color characterization is process of converting RGB system to CIEEXYZ and CIEELEIB system. It is related with color gamut mapping technologies, which is related with calibration, the practical use of the technology. The printers, other than display devices, use CMYK in inkjet printing devices. Other than RGB system, CMYK represents cyan, magenta, yellow and black. Blend of all these maximum intensity becomes black while RGB becomes white. CMYK is based on subtractive mixture of colors. The digital color processing is relied on many other principles, including visual appearance models, which are areas of physics, the convergence of interdisciplinary ways. This book also covers this topic too, physical principles, optometric principles, and color profiling principles. The example formulae are provided with basic arithmetic styles, and introductory for no hassle. A little bit of knowledges about rate of change and function notation are familiar to readers. The formulae in this book can be fully understood even when we study without help of mentor. The most strong feature of this book is reviewed as the above. The amazing detail and clarity are warranted. If we must choose only one book, this book is the choice. Great book to be recommended.